So I have this table saw, and it's pretty basic. It just has a simple fence. I also have a mitre sled that I can put on there if I want. And around the back it has a dust collection system. It's just a port coming out the back there, which goes into this cyclone and eventually into this vacuum cleaner. And running it is pretty simple. There is a switch under here, and the annoying thing about it is I have to remember to turn on the vacuum every time I want to use it before I turn on the table saw, and often I forget to do that and I'm cutting away and dust is going everywhere. So what I wanted to make is a remote switch that will turn on the vacuum whenever I turn on the table saw. But I want it to be entirely remote. I don't want to have a cable running across here. So I'm going to do it using a couple of Arduinos and some RF modules. This is the schematic for the remote switch. It's made up of a transmitter and a receiver, and both are powered by an Arduino Nano connected to this NRF24 module for the radio communication. The transmitter has a current sensor which will detect the current going to the table saw and switch on the vacuum if it goes above a certain threshold. And on the receiver side there is a 5-volt relay which will switch on the vacuum given that signal. On both the transmitter and the receiver there is a status LED which will switch on when the vacuum is on. And this is useful because the table saw makes quite a lot of noise and I can't hear the vacuum when the table saw is on, so just to know that the vacuum is on, we've got this status LED. And on the transmitter side, the status LED is actually driven by the acknowledgement packet coming back from the receiver. So you know that the vacuum has definitely received the signal to turn on, and it's not just that the transmitter is working and then the receiver is not working. Both of these circuits are powered by a 5-volt DC supply, and you could just use a simple USB power supply for this, but the enclosure that I'm building it into is quite small, so I'm actually building this small power supply unit. Here I've got both parts built up on breadboards. This is the transmitter, this is the receiver, and the transmitter has a manual switch attached to it, as well as this current sensor. The current sensor is not plugged into anything yet. Also the relay is not plugged into anything because I've kept all of the main stuff outside of this. The 5-volt DC supply is also missing from here. The next step is to program the modules. So I've got the code here, and I've got the transmitter module set up over here, and I'm just going to plug in the USB cable. That'll allow me to program it. So I'm using Visual Studio Code for this. You can use the standard Arduino one, but I quite like Visual Studio Code. It's what I normally use. This is the transmitter code, and to program it, it's pretty simple. You just go to this Platform IO section here and find the transmitter environment, and we can build it to check that it builds okay. It does. And so I'm going to just click upload, and away it goes. That's it. It's written to the Arduino. Now we can switch to the receiver. And the same thing. I'm just going to upload the receiver code. One thing to just mention about the receiver code is I've added a bit of extra code here that will persist the vacuum on for a certain amount of time. And this means that the vacuum will stay on for a certain number of seconds after the transmitter is turned off. This will allow the vacuum to carry on running and to clear out any dust that's left in the pipe. Now with the code uploaded to both modules, I can test it out. So we have the transmitter here with the manual switch and the receiver here. So when I turn on this switch here, should trigger this relay to turn on, and also this status LED. and this status LED on the transmitter here should also light up. So let's try it out. It works. This is a flashing LED just because that was the only LED I had lying around. And now when I turn it off, I'll flip this switch and this status LED should go out straight away because there's no ACK packet coming back from the transmitter. But this status light for the vacuum should stay on for 5 seconds and then go out. There you go. So now with the prototype working, the next step is to get it built up onto some strip board. That's the receiver done. I just need to do the transmitter. And that's the transmitter done. Next thing I need to do is just create some DuPont cables to go from this board to the other components. So I've finally got all the cables put together. I really hate these DuPont connectors. So now what I need to do is just wire it all together. So I'll just give it a quick test plugging it into USB before I test the mains regulator. Seems to work. This is the underside of the high voltage section of the board, and as you can see I've isolated it pretty well with cutting the strips, but what I want to do is just cover this in hot glue just to be doubly sure that nothing's going to be touching that. Now I can just use these crimp connectors to connect it up to this mains cable. To enclose the boards, I've got these two plastic enclosures and I need to make a few holes in them. For the transmitter, I have this 4-way. I'm just going to run it in line straight through one of the boxes. And I have 2 of these cable glands that I can mount either side. And for the receiver, I have this extension cable that I was going to do the same thing with to power the vacuum, but then I realized I have one of these old drywall boxes that I could just mount straight in here, and there's plenty of room for it there. And I have one of these old switch plates, so I think that'll work better. And for this front plate, I just need to cut an opening for it just here. So I need to cut a square just here. I think I'm going to mount this relay in the base of this drywall box. So I'm going to need a hole for this to come out. And I'm going to drill that just here. Now for the transmitter, I want it to be mounted in the box, about like that. So I'm going to cut the cable here. The front plate for the transmitter, I need to have a hole for the switch and the LED, so I'll make those here. I think I'm going to mount the current sensor right about there. Just going to secure this cable a bit with some sticky pads and some zip ties. So on the receiver side, the power supply turned out wasn't working properly, and so I removed it and I was going to put a new one on, but I realized that I didn't leave enough space for this drywall socket to go in there anyway. So I think I'm going to have to revert to a different method to power it. So I found this old Apple adapter here, and this is quite small, so I think it'll fit. The trouble is where to fit it. I can't put it in there because I'm using that for the relay module, but I think there's a nice space under here I can make it fit. The problem is that I'm going to need to take off these pins in order for that to work. So unfortunately my camera cut out on me and I didn't have the footage of me cutting off these pins. I just cut these off with an angle grinder. And now I'm just going to solder these wires onto here. Now, because this is just soldered on here and there's nothing actually mechanical holding it on, I'm going to cast this in epoxy resin and I'm going to stick it this way up onto the inside of the lid. So it should be there solid and not come off. So I want to have all of the neutral connections connected together and the earth connections connected together, and I'll do that via this plate here, and the live connections will be switched via this relay and then go back into here. I'm gluing this RF module just on the side here. I'm not going to glue down these boards because I might need to take the Arduino out to reprogram it. Just going to give these a quick test run before I put any load on them. Both LEDs are on. Turn it off. And now testing with the table saw plugged into the receiver. When the table saw turns on, we should see both the lights in the transmitter and the receiver turn on, and then when I turn it off, the receiver should stay on for an extra 5 seconds. I was originally thinking of mounting this on this French cleat wall here, like this, but I think it might be more space efficient if I mounted them like this. The problem with that is this is now coming out of the wrong side and it's now upside down. So I was thinking I'd have to reverse all of the stuff that's inside here, but actually all I need to do is just flip around the lid. And I think I'll mount them on this old board like that. So now with the table saw hooked up to the transmitter and the vacuum hooked up to the receiver, when I turn on the table saw,